Kubernetes is in production clusters around the world, and some of those clusters have hundreds of thousands of containers. Kubernetes provides a distributed systems management environment for small startups and giant enterprises, with applications ranging from microservices to machine learning pipelines. Because the use cases of Kubernetes are already so wide-ranging, and the project has had so much adoption, the focus on many of the Kubernetes core contributors is stability. Clayton Coleman joins the show today to talk about the impact that Kubernetes is having on software engineering and the efforts of the community to improve stability. Clayton is the lead engineer for OpenShift, a platform as a service from Red Hat that is built on Kubernetes. Autoscaling, monitoring, and etcd are a few of the topics that we discuss. Improvements to each of these areas are making Kubernetes easier to work with. There's a possibility that the Prometheus monitoring system will get pulled into Kubernetes itself, and we explore the pros and cons of this architectural decision. From his experience working on OpenShift, Clayton also has a lot to share around the idea of a platform as a service. Platform as a service tooling can make enterprises significantly more productive. It serves as a layer between a cloud provider and a developer that is shipping application code. It's always surprised me that there are not more organizations that have adopted some form of platform as a service. Cloud providers can be complex to learn how to work with. As enterprises adopt cloud more aggressively, they are using platform as a service tools as an interface for developers to work with these clouds in a more opinionated way. Kubernetes is used as a foundation for platforms like OpenShift, because Kubernetes can orchestrate resources on a cloud in a way that makes it easier for a deployment to be multi-cloud or portable between clouds. In our previous episode with Clayton 2 years ago, we covered the basics of OpenShift, if you're curious about that. We also talked about the developments that were occurring around Kubernetes at the time. In today's show, we go deeper into how the Kubernetes ecosystem is evolving today and Clayton's personal experience working on OpenShift. Full disclosure, Red Hat, where Clayton works, is a sponsor of Software Engineering Daily. Today's podcast is sponsored by Datadog, a cloud-scale monitoring platform for infrastructure and applications. In Datadog's new container orchestration report, Kubernetes holds a 41% share of Docker environments, a number that's rising fast. As more companies adopt containers and turn to Kubernetes to manage those containers, they need a comprehensive monitoring platform that's built for dynamic, modern infrastructure. Datadog integrates seamlessly with more than 200 technologies, including Kubernetes and Docker, so that you can monitor your entire container infrastructure in one place. And with Datadog's new live container view, you can see every container's health, resource consumption, and running processes in real time. See for yourself by starting a free trial and get a free Datadog t-shirt at softwareengineeringdaily.com/Datadog. That's softwareengineeringdaily.com/Datadog. Thank you, Datadog. Clayton Coleman, you are the lead engineer of OpenShift. Welcome to Software Engineering Daily.
It's great to be here. Excited to talk.
Yeah, we last spoke a few years ago, and since then there have been lots of developments in the Kubernetes and the OpenShift space. What's an example of a development that represents stability? Because I think there's been a focus on stability in a lot of the recent work in the Kubernetes community.
It's very interesting. I think the last time we spoke, there was a lot of talk about features, and a lot of people were asking the question, what can Kubernetes do for me? I feel that now most of the discussions I have are around is what do I need to do to run on Kubernetes? So I know there's a lot of work that we've done, I think in the last 3 releases since we talked in Kubernetes, that really just focus on doubling down on the base pattern that Kubernetes enables, on educating the community, on trying to streamline painful parts operationally. And stability is a really interesting one because as more and more people come to Kubernetes, as more workloads run on Kubernetes, it's actually been very interesting because with that diverse set of workloads, there's actually a lot of challenges because not every workload, not every type of application, whether it's you're running your cloud-facing web application, or you're running an internal database, or you're running a legacy software that you just ported over, each one of those has specific use cases, and Kubernetes doesn't always support all of the things. And so it's a delicate balance actually between people who are betting on Kubernetes, making them successful by fixing rough edges on the APIs or adding new features to storage to make storage easier to work with, making the core product more stable, but balancing that to, what do we say no to? What do we not add to Kubernetes, and how do we allow people to still, succeed? Because to be honest, we can't do everything. And that I think is the hardest problem in software engineering, is not doing things.
Tell me more about that. Tell me more about the difference in when we last spoke, which was a couple years ago, when the focus was more on features. Like, what would be an example of a feature, and what would be an example of a stability effort that has been implemented more recently?
A great stability and evolution has been etcd, which is the database that backs Kubernetes. The last time we spoke, we were still using etcd 2, which was designed before Kubernetes even existed. And there's a ton of work in the etcd community to make Kubernetes, to solve the Kubernetes use cases at the scale Kubernetes cares about. So, tens of thousands of applications, hundreds of thousands, or maybe even as much as 1 million containers running on that cluster. And we were just rolling it out at the time. And there's actually been a lot of, there's still parts of the Kubernetes ecosystem today that are still on that older version of etcd, because we've tried as much as possible to make it a choice that, even though you get these big benefits at larger cluster scales, we know that the transition is really rough. And so focusing on that, or trying to make it so that the transition is not rough, but that the risk is acceptable to someone who has made these big bets running production workloads on Kubernetes, that they're not impacted. There's a ton of other little details. Extensibility of Kubernetes is one of those real features that the last time we talked, we were talking about adding extensibility, and the first elements of that with custom resources and aggregated APIs, and making it easier to plug hooks in to Kubernetes so that you can add your own policy. Those features since then have moved to beta or GA status. They're available to use, and they promise not to break them. And we've seen a ton of people adopt those. Projects like Istio and Knative, which are built on top of Kubernetes, are actually leveraging those features to provide true extensibility. And there's some things that we'll obviously need to change on that to make it better. But that effort has started to pay off. But of course, it's funny because even though it's been a year or so since we talked, it's probably another year or two while we work through the implications of, do we have all of the right extension points? Can we continue to help people add new workloads? What if someone wants to do real-time voice communication on top of Kubernetes? Some of the needs don't quite fit with what Kubernetes is capable of today. Those might require changes to Kubernetes itself. What extension points are we missing? As far as features, I think the biggest transition in Kubernetes so far has been Kubernetes 1.9 brought the workload controllers, the replica set, the deployment, the stateful set, and the daemon set to a V1 GA promise we'll never break these ever, ever, ever state. And to me, I think that makes Kubernetes the first version of Kubernetes done. A lot of the other things around that are the supporting technologies and will continue to evolve. But those workload APIs are the heart of Kubernetes. And even though there's plenty of exciting stuff that we might want to add, getting to that point of saying these APIs are probably never going to change. I hope 10 years, 15 years from now, people are still able to use those APIs without change, and kind of have the confidence that even as the project gets better and better and adds more capabilities, that everything just keeps ticking over without them having to worry about it.
That must feel great. Extensibility. So this is like if I want to build Kafka as a service with Kubernetes underpinning it in intelligent ways, or voice APIs, and that's distributed system stuff that would be necessary to write a Kubernetes extension for, as you mentioned. Can you describe that in more detail? What's the spec for a Kubernetes extension, and why do we need different extensions for different kinds of applications?
The easiest thing to say would be that you don't need to. You can just run, you could run your APIs on top of Kubernetes and program Kubernetes any way you want and use it as an orchestration system. And there's really no need to fit into that. Some of what we've seen, and I think, at Red Hat, working with enterprise customers, this is something that I deal with a lot, is there's always an edge case, whether it's in your workload, in your operational policy, in the human processes, who can do what and when. And those edge cases, it's always kind of a balance between, well, you can say, well, just paper over that, provide your own layer on top of Kubernetes, and trying to meet the people who run and use Kubernetes in the middle by saying, well, even if we're not going to go add this knob for you, here's a way that you can add the knob yourself and make that hook into the points as limited as they are within Kubernetes. So a great example is policy. There's some built-in policy in Kubernetes to do things like role-based access control, who can do what and when. There's hooks like audit. One of the mechanisms for extensibility lets you add your own hooks. So you can, run whenever someone makes a change to a pod, or when someone connects to a pod to run a shell command inside one of the containers in that pod, giving someone the hook that they can insert their own business logic, over a remote HTTP call or to a web service or to a functions as a service running on a cloud provider. That sort of hook is a pretty normal escape hatch for people developing on Kubernetes. The second half of that is maybe what I would call Kubernetes native applications. So if you're running, half of your workloads on Kubernetes and you benefit from saying, well, we're going to use the kube control command line to deploy all the applications, or we want to use Helm to wrap that all up and make that be a problem we don't want. Or if I'm going to write an operator, like a bit of code that's going to go continually make sure that a particular characteristic of my database, keep my database running and self-tune it and self-monitor it. In all of those cases, if you build something on top, you don't get the benefits of the other parts of the Kubernetes system, like role-based access control or audit. And so the idea of adding new declarative APIs to Kubernetes, whether that's a real simple, hey, I want to have my database as a service, so I'm going to create an API object that describes a database, and say it's a Postgres database, and I want it to have 300 gigs of storage, and I want it to be in a master-slave failover configuration. Making it possible for people to build those in a kube-like fashion means that you can then apply access control. Who in the team is allowed to go create this Postgres database type? And so it's not required that Kubernetes be extensible in this fashion. It's not required that people build their extensions. But I think over the last few years, we've seen a huge number of people in the ecosystem wanting to be more Kubernetes native because it makes them more efficient. Organizations that go all in and say, we want to run everything on Kubernetes. And not only do we want to run everything on Kubernetes, but we want to kind of standardize our operational tools across that. And then that gives us consistency across cloud providers because we can run Kubernetes on all the different cloud providers. And so if they're going to invest in building a standard API, being able to build that in a kube-like fashion so that it fits with all the other bits that they're running on kube makes the operators' lives easier, makes the development teams easier. It means you can test these across clusters. So there's a nuance there that no, it's not required, but it does mean that you get more of the benefit. And there's people helping you make your features and your needs cloud native without you really having to do it yourself.
You were talking earlier about the upgrade to etcd. So what is it, from etcd 2.0 to 3.0?
That's correct.
So etcd, that was based on the Google Chubby paper, right? It's the lock server.
Correct. It's a really simple key value, high availability. It builds on the ideas of, well, if you're going to have this server that's highly available with a very simple protocol to keep it highly available, it's not a full database. It doesn't offer indices, or it doesn't offer a very nuanced access control system. But what it does do really effectively is store somewhere between 1 and 10 million keys. And if those keys are just simple JSON objects, you can actually make, I think Kubernetes is proof that as long as you're not trying to get into the hundreds of millions or billions of entities, etcd works really well at, it's funny, at Red Hat, we've run etcd HA since the very first version of Kubernetes that we shipped and supported. We've had challenges, and almost every challenge that we've ever hit running etcd in a three node configuration, in highly available 3-node configuration, was almost always a network problem, a hard disk problem, or an operator problem, accidentally turning something off or deleting it. etcd has been one of the most reliable pieces of software I've worked with, and it's got its quirks like anything else, but it really is just the simplest possible thing that works, and Kubernetes has been able to leverage that.
Well, I always thought it was a testament to the work on etcd that when Kubernetes was started, it used etcd, despite the fact that at Google, I'm sure Brendan Burns and the other early Kubernetes people could have looked around and taken a look at Chubby itself, or whatever the Chubby service is internally. Although I guess maybe Chubby was like tightly coupled to Google infrastructure, and maybe it did enough similar things to etcd, or etcd was, in any case, etcd was good enough that Google was willing to pick it up off the shelf, which is that's a real testament to the work on that project.
It's also, I'll be honest, the Google engineers who started Kubernetes and opened it up for the rest of us to join, they were pretty pragmatic, and I know that they had some internal discussions about this and that. And even after we started the open source project, we talked about other databases. I think simple, highly available software is really rare, and Kubernetes in a highly available configuration, where the Kubernetes masters can tolerate downtime from one or more nodes, one of the 3 masters or more if you run that. It's actually worked really well. I could count on one hand the number of times that's been the problem versus something like, I just accidentally deleted all of the machines in the US East region or something like that. And as Kubernetes gets more powerful, I think one of the things that I'm always on the lookout for, and I know others on the architecture side of Kubernetes are really trying to think about, how do we do the minimum that we need to make the most things happen, and try to keep things as simple as we can, because there'll always be the pressure and the desire to add more features and more capabilities to Kubernetes. But if we can kind of round that off at some point and say, everything past this you can build on top or alongside, that's good, because it keeps us from having to continually make Kubernetes more and more complex. If Kubernetes is done, for a 95% level of done, that means that people can rely on it and focus at other areas, focus on things that actually drive their business.
I don't know if you worked on it at all, but did you see what the updates to etcd were, the improvements?
There's I give full kudos to the team at Core OS. When we first started Kubernetes, folks from Red Hat and folks from Google and folks from Core OS, we had a large number of discussions about the design of etcd 3. And the etcd team had a set of really clear improvements that would double down learnings from the version of etcd 2. And etcd 3, the changes were built in reaction to the use cases of Kubernetes. There was a lot of discussions and, performance tests. We kind of ballparked how big we thought Kubernetes would get and the kinds of cleverness Kubernetes might need to support the use cases and patterns. So for instance, if you have 1 million pods and you need to go through and make sure that none of those pods are using the same IP, that's a certain requirement on etcd, the ability to do a really large consistent list that the etcd team took and built into etcd specifically to allow us to do that. There's a lot of inside baseball, but the key thing about etcd is that I really love is it is built on this idea that you have a list of things and then you can see all the changes from a point in time. And then if you get disconnected or you got to go back and resync, you can list again and start watching from a point in time. And very few other databases even have that capability. Postgres, Oracle, some of the high-end databases have a more complicated version of that feature. But in etcd, it just works, and it's allowed us to really build Kubernetes the way we want. And the etcd team really designed etcd 3 around Kubernetes.
Well, I remember there's a distributed systems problem called Snapshot, where you try to take a snapshot of the state of a distributed system, and it turns out to be kind of hard to do that. That sounds like what's the improvement that needed to be made, or maybe it was an improvement to Snapshot, or Snapshot's not straightforward.
It is the etcd kind of has the simplest possible snapshot mechanism that a mere mortal can use. And I will say, even in Kubernetes, we're always finding subtle things, but we didn't start from a complex place. We didn't try to layer a simple system on top of a complex underlying schema. We started from a simple schema that does the couple of core things that we needed. And Kubernetes takes those patterns and controllers and operators in Kubernetes. When we say those words, we're really meaning it's just a really stupid, simple for loop over a list of items. And when something changes, we get notified. And we try to keep that as stupid simple as possible because as every engineer knows, only stupid, simple things ever end up actually working.
Accenture is hiring software engineers and architects skilled in modern cloud-native tech. If you're looking for a job, check out open opportunities at accenture.com/cloud-native-careers. That's accenture.com/cloud-native-careers. Working with over 90% of the Fortune 100 companies, Accenture is creating innovative, cutting-edge applications for the cloud. And they are the number one integrator for Amazon Web Services, Microsoft Azure, Google Cloud Platform, and more. Accenture innovators come from diverse backgrounds and cultures, and they work together to solve clients' most challenging problems. Accenture is committed to developing talent, empowering you with leading-edge technology, and providing exceptional support to shape your future and work with a global collective that's shaping the future of technology. Accenture's Technology Academy, established with MIT, is just one example of how they will equip you with the latest tech skills. That's why they've been recognized on Fortune 100's Best Companies to Work For list for 10 consecutive years. Grow your career while continuously learning, creating, and applying new cloud solutions now. Apply for a job at Accenture today by going to accenture.com/cloud-native-careers. That's accenture.com/cloud-native-careers. I want to talk to you a bit about scale, because I think Kubernetes has really been tested by some of the people who are using it. There's a lot of great case studies on the Kubernetes website that I've read through, and there's some just great stories there and interesting software architecture, ways that things are configured together, like cost savings that people are getting out of Kubernetes. I've heard that the biggest publicly known Kubernetes cluster is JD.com, which is like the Chinese Amazon, and they have a cluster with like 100 to 200,000 containers, which is really big. So at a deployment of that scale, what does a company have trouble with? Like, is that deployment, I guess we don't know if it's a single cluster, or if it's a series of clusters, or how those things are orchestrated together, but what are the kinds of problems that emerge at that scale that have perhaps revealed, issues in Kubernetes that only have presented themselves once you have that like sample size of number of containers?
I can only talk about this vaguely, but that's a pretty big cluster. I get bug reports every day from clusters that are even bigger. But I think that actually kind of is a good upper bound. If someone came to me and they said, how big, what's the biggest I should run on Kubernetes? I think, somewhere between, 500 and 1,000 or 2,000 nodes is a good size. If I know there's people out there who have, for instance, in Kubernetes, a namespace is a subdivision of like a kind of like a project on other systems. I know there's people who have 45, 50, 100,000 namespaces. And I do know of people who have, a lot more containers than on a single cluster. Most of the challenges are sooner or later, at some level, you're going to hit a non-obvious limit. And so a lot of people kind of grow into those sizes. So they might plan big, but they'll incrementally grow. People will come to the platform. You might have 10 or 12 clusters, but one of them is your dev cluster. And so people tend to congregate there because it's, fairly loose. You run some test applications and then you forget to turn them off. A lot of what happens there is kind of the two classes of problem. One is you hit some non-obvious limits. So some of the ones that, have definitely been hit over the years are IP tables. So once you have a certain number of services in a Kubernetes cluster, if you're using the IP tables implementation, you're going to run into a challenge with you're actually just managing a giant list of rules in the kernel, and you got to take a lock to change it, and you got to file all that into the kernel, and then the kernel's got to go apply all those rules. Certainly on some very large clusters, we've seen it take 10, 15 seconds for a single change to a service to take place in IP tables, which obviously, prevents applications from seeing updates. And so, that was kernel fixes. There's some work that was done in Kubernetes to add a new type of proxy. A lot of the network providers for Kubernetes. So there's plenty of different network providers like Calico and Flannel, and different providers actually have different optimizations here, but everybody kind of hits some limit where someone was like, surely you'll never have 200,000 IP tables rules. Well, guess what? We did. I also tend, and interestingly enough is, and I've said this a couple of times when we're talking about scale and etcd, is we typically don't hit etcd scale limits. We hit limits everywhere else in the system where someone has an inefficient scheduling rule, which works great when you're testing on 200 pod clusters. But if you have a really inefficient scheduling rule, it doesn't even have to be, worse than linear. It just doesn't work when you have 200,000 or 1 million pods to schedule among. And so I think the last 3 or 4 years has really been trying not to change too much in Kubernetes so we kind of invalidate, but just, as people grow in size and they try their new workloads, we find a limit, we fix it in the kernel, we fix it in user space, in the drivers and the networking stacks. We fix it in the networking plugins. We fix it in the storage plugins. There have been some very amusing problems with some of the large cloud providers where if you attach and detach persistent volumes at a high enough scale, the cloud provider doesn't really like that. And so, working with the cloud providers to try and get those issues fixed is kind of some of that day-to-day that I go through, and folks at Red Hat and folks in the community, where we're trying to kind of just, it's not really a design problem. You're just nailing in every, software is a big place these days. You're gonna have to fix a lot of little things. And I think some of what our responsibility as a Kubernetes community is Kubernetes won't be stable if we prioritize change and new shiny over the kind of boring, iterative, but important, keeping the core the same enough that you can fix the problems, not introducing exciting new problems. And I think that, the Kubernetes community as a whole has been really, really good at that, and trying to, when someone comes to Kubernetes, the community, and they really need a feature, being open to the discussion about, do we really have to fix this, or can we add this feature, or can we look to repurpose an existing feature to solve it? And I've been pretty impressed that people who come and use Kubernetes at scale, and even the people who don't use Kubernetes at scale, but who depend on it for their businesses or their startups or their home projects, have been pretty good at understanding that trade-off between features and changing only the things that you need to.
The big idea of Kubernetes is shiny enough. It's like, let's simplify distributed systems like Linux simplifies single node operating systems. That in itself is a big idea, and it's a hard idea to execute on, and it's going to take a long time. And I think that probably is, that's reflected in the kind of humility and the focus on boredom that you or Brendan Burns or Joe Beda or any of these people who've been in this space for a while, they recognize it. And I think the long-term vision is inspiring enough. Like, I hear when I talk to Bitcoin people, for example, like the Bitcoin people who have been in the community for a long time, they are fine. They're inspired by the idea of making Bitcoin boring, or making Ethereum boring. Like, what are we working on in Ethereum? Scalability, right? Like, it's just, let's just like get scalability. We can keep things boring. and get scalability, and then like people can build stuff on top of it, and that can be the inspiring shiny layer, and I can get validation knowing that I built the hard boring stuff underneath that and take advantage of that.
It is funny because after almost 5 years now working with Kubernetes, I occasionally do want something shiny and exciting. And fortunately, there's a lot of really smart people in the Kubernetes community who talk me down. I sometimes have my flights of fancy just like anyone else. And I think if the community does its job right, you can go do the shiny experiments on top of Kubernetes. And if we can do our shiny experiments on top of Kubernetes, that means that others in the community can run their billion-dollar businesses on top of it, trillion-dollar businesses on top of it. And I think I can't say exact numbers for sure, but I'd be shocked if more than 10% of the Fortune 500 didn't run Kubernetes somewhere. And somewhere. And at Red Hat, I've often been privileged to talk to some of these really large enterprise customers. And I think an important part for me is trying to balance the needs of the big and the small in Kubernetes, because the vast majority of Kubernetes clusters are small. Probably 95% of all clusters have less than 5 or 6 nodes. And that's good, because that means that the technology works really well for the simple things and isn't fat and bloated and complicated. Yeah. And we can still scale it up. And the nice thing is, as the old adage goes, every complex system started off as a simple system and evolved. Start keeping the idea of we should work on a very small cluster and make sure it's capable of scaling without over focusing on the complex use case, because complex systems are complex. Big enterprise software is complex enough as it is. If we can offer a simple layer that they can run on top of, they can still accomplish the complex objectives that they have, but they're able to trust and rely on that simpler foundation.
And so I was going to ask you about like the optimal size of a cluster, and should a large company just have some centralized Kubernetes cluster? But it doesn't even seem like a super important question at this point, because it seems like if you're talking about a Fortune 500 company, maybe a trading company, like the trading side of the house doesn't talk to the, billing side of the house, and they might both stand up Kubernetes clusters for some specific application. One of them has 5 nodes, one of them has 10 nodes. Somebody on the UI, trader UI team somewhere else is standing up a different Kubernetes cluster, and maybe over time they find ways to merge these to get economies of scale or something. But today, you just have independent teams within these giant organizations, and they're not talking about let's have the central command of the Kubernetes, or maybe you do. Maybe you have a platform engineering team that ordains that.
It happens. However, I think even those platform engineering teams, at the end of the day, you have to think about your failure domains. And because Kubernetes is trying to be a distributed system that hides some of the details of distributed systems, or at least makes them more approachable, it does have to think about those failure domains. And, credit where credit's due. In the very early days of Kubernetes, we had a lot of lunch discussions about making sure that Kubernetes worked really well in one or a small number of failure domains. So, working in a single zone, or working across 2 zones in the same region on a cloud provider, working across 2 or 3 data centers that are co-located. That sort of failure domain is important. But obviously there's human failure domains. What if the trading team starts an upgrade and takes down the banking team? And so I think what we're seeing is, in the early days, a lot of people had their big clusters. I think the only direction I've seen recently has been people asking and wanting the tools that make it easy to run multiple clusters, and sometimes to stitch those together and sometimes to keep those separate. So you might want to keep your audit policies and your security policies consistent across clusters, but the workloads might be completely different. You might tune them. And a lot of there's a bunch of great efforts going on in SIG cluster lifecycle and in the multi-cluster SIG and in the machine and the cluster API SIG to actually make it easier to instead of install of a cluster being such a big dramatic event, to take advantage of the fact that most people are running on top of flexible infrastructure, whether that's a cloud provider or a virtualization solution on premise, or even bare metal, and use the APIs that are latent in the environment to actually let the cluster ask for more resources or give them back. That's what we do for storage, and it's what we do for load balancing. And we're getting close to the point where that's something you can do for machines. So the machine API in Kubernetes is actually something I'm really excited about, because it means that most Kubernetes nodes are going to be pretty opinionated. You want them to look a certain way and have a certain set of software and have a certain version of the kubelet. And once you've kind of got that settled, well, shouldn't I have built automation that makes it easy to ask for another machine that looks exactly the same? And when we do that, that'll make it easier to say, well, you could install a very small cluster and you don't have to go back to your installer and ask it to change the size of your cluster. Your cluster actually controls that. And I think that's going to be a big change both for people deploying their own clusters. So, the folks who don't choose to opt into one of the cloud providers' Kubernetes as a service offerings, but want to run them on their own, or don't like the trade-offs that the cloud providers make for them, or want to be consistent across cloud providers. When they make those choices, I think there's a lot of tools coming in Kubernetes, and I want to see the community double down on making the cloud providers and the virtualization environments and even bare metal kind of just be another thing that we program, because that's kind of the Kubernetes way, to be honest. It's just another API, hide the details, focus on the business value.
What you said about failure domains is really interesting to me, because with Kubernetes, at this point, we've talked about the fact that there's so many different use cases that the project will address, and you have no choice but to constrain your scope to something. And I like the idea of, let's just constrain it by like distributed system configuration. Like, let's solve for the 5 nodes, and there's going to be tons of failure cases and edge cases and stuff, but we really need to get the 5 node or 5 or less nodes use case done. Okay, we need to get 2 availability zones. Like, that in itself is going to have some hellish distributed systems and cloud provider problems to figure out, but it's still kind of a small, modest problem in the scope of things. And if you solve for those, eventually you get to the point where you have a SIG for big data, or a SIG for machine learning, or multi-cloud cross geo replication, or stuff like that. And you can have faith that the basics are covered when you're moving on to those like really hard ones.
Absolutely. And the interesting thing, and I think this is an underappreciated discussion point when people talk about adapting Kubernetes, is that Kubernetes is automation of application environment. So it's providing you a place to run Linux and maybe some Windows software here and there. But it's providing you an API to use. If you don't automate the other side, how you deploy and test software, you only get half the benefit. And I think when you combine a development process that focuses on automating the boring stuff, where you're pushing code and deployments happen, where your tests get run automatically, and then if everything passes, a human might just give a sign off in chat. When you have those processes, Kubernetes really shines, because if you have multiple clusters, at some point you're probably going to have to talk to a third cluster, or the original cluster might go down. And if you've got that automation for deployment, redeploying to a different cluster should be, okay, well, I'll change the constant that says what cluster I go and deploy this application to, or I'll change the load balancer address so that most of the traffic is going to the healthy cluster. That sort of mindset, everybody who uses Kubernetes, I think, is painfully aware of that. It's not something we discuss often. The flip side of automated infrastructure is that you need to automate your development processes. And there's a lot of good things happening. The Knative project, which was launched at Google at GCP, Google Cloud Summit, I can never remember the exact name, was launched this year, was a collaboration between a bunch of organizations that are trying to make application development on top of Kubernetes easier. And there's kind of a broad agreement that Kubernetes has a good set of workload primitives, like I talked about. There's some specializations that you can do for some use cases, like simple web services or functions as a service, where you actually get some advantages if you can constrain the problem even more. It doesn't force you to use it. But being built on top of Kubernetes means if you build it on top of Kubernetes and you have an incentive to go, say, make pod startup in Kubernetes really fast, that doesn't just benefit this new use case you've created, it benefits everybody else. So Knative is actually a great example. One of the working groups in the Knative community was trying to make pod startup faster so that they could do more functions as a service type of iteration flows.
Cold start,
exactly.
Cold start problem.
And so actually, some Googlers and some folks from Pivotal had done a good breakdown of where some of the time was. And one of the Red Hat engineers on our kubelet team actually said, that's funny. And they took the listing and they actually realized that we were waiting for 300 milliseconds for absolutely no reason in the kubelet. And a one-line code change got us 300 milliseconds on all pod start or all container start times across every Kubernetes deployment. And that'll change will be in Kubernetes 1.12. And so I always like having those kinds of incentives lined up. Like, I want to make Kubernetes really fast. Great. So do we. We'll help you help us. That's kind of actually been a really exciting thing. So it's like that app development on top of Kubernetes finds use cases and finds bugs that helps folks who are, just running databases or running stateless web applications.
That is really cool. So you said that there are times where you, as an engineer, and I think most of the engineers in the audience probably have this, where they feel like, I've been doing this thing that I'm doing for a while, or, on the weekend, I wake up and I've got an open calendar and I want to do something shiny and fun, but maybe it relates to what I do at my everyday job. So you probably have some desire to build things that are shiny. Although I know with OpenShift, which is the higher level platform as a service that is on top of Kubernetes that you work on at Red Hat. So that is, you're also focused on, I think, kind of stability and keeping things boring. I can imagine shiny things from OpenShift emerging eventually. Like, I can imagine that eventually getting to the point where shininess maybe even is the focus rather than, but Kubernetes, I can imagine being boring for a very, very, very long time. Is there a particular place where you find your shiny feature desires satiated? Are there any projects that you're working on specifically?
It's interesting because the more opinionated and optimized or efficient a particular workflow is, whether it's a particular way that you build applications and push them, the more likely it is that somebody else also has an opinionated flow that's different from yours. And you can never convince another developer to change whether they use VI or Emacs or Visual Studio Code, or at least it's really hard. That sort of opinionation, I think, what I like to look for in the Kubernetes community, the things that get me excited are, how do we bring together different problems that people have with a solution that kind of works across those multiple layers? And so the Knative project mirrors things that have existed for a while before. So things like Heroku and Cloud Foundry, OpenShift. The previous version of OpenShift actually had a simpler developer flow. I've kind of been spending a little bit of time trying to think about that abstraction of a simpler iterative dev flow on top of Kubernetes. There's 1,000 different ways that people have approached that in the last few years. Projects like Deis adapted to run on top of Kubernetes, and they had workflows that made it really easy to quickly iterate. Some of the folks at Deis took those ideas and created tools like, and I'm going to blank on the name here right as I'm going to say it.
Helm?
Well, Helm is one of them. There was the dev tool, Draft. And Draft, quick iterative flow. And, as a programmer, one of the things that I always try to get excited about is how do I make my quick iterative flow as easy as possible? So looking for things on top of Kubernetes that we can put into OpenShift and try out, but then learning from others from the community and adapting those. So, projects like Knative are a bunch of people who might have worked on some of these problems before, taking another look and trying to make it simpler. I've spent a lot of time recently actually just using Kubernetes as a target for running builds. So one of the things we do in OpenShift is we have an API for doing Docker builds on top of Kubernetes. And that's work that we also worked within Knative to kind of evolve and to drive forward. But at OpenShift, we actually do all of our CI for building OpenShift, we build images and Docker images that run on top of Kubernetes. We do that with OpenShift on top of Kubernetes. So we're kind of using our own product and our version of Kubernetes and our APIs as a dog fooding environment. And when you make it so that the developer's CI system depends on the product tends to get pretty stable because there's nothing developers hate more than having to actually go debug why the CI system isn't working. And so if we can combine that with, Kubernetes crashes in this one weird mode, if you can tie the incentive of, I really want my CI job to complete so that I can get this PR merged to get in the next release, you can tie that to, hey, the thing that you're building and contributing to could be more stable. And, I need the debug tools that make it easy for me to go figure out why a job didn't work on Kubernetes. Trying to line up those incentives so that, every day, people are contributing code to OpenShift and Kubernetes and projects in the ecosystem like Cryo and, a billion other projects, the operator frameworks, trying to make it so that every time someone opens a PR, they're helping make Kubernetes just a little bit better. Because people are working on saying, I need Kubernetes to just work. Like I want it to be boring because if it's not boring, my CI jobs aren't passing. So there have been a lot of exciting bugs and interesting tweaks to Kubernetes that I've personally found. I think maybe the next interesting thing is going to be trying to get involved in what can we do to make resource management on Kubernetes better. So a lot of great work that's come out of the scheduling teams and the monitoring teams and the metrics teams. I'd actually like to, in the next year or so, see Kubernetes get to a point where when you schedule a workload on Kubernetes, if you didn't know exactly how many resources that was going to take, that's okay. Kubernetes knows how much it took the last time, or it knows what similar workloads are doing. And we're getting there, but I really want to see that. I want to see that loop closed so that if you're running workloads on Kubernetes is using the data it itself has about how the workloads are running to make the cluster more efficient, to tie that into autoscaling of the cluster itself. So you get cheaper clusters because you don't use nodes. And there's a lot of little details on that. And that's one of the projects that when we started Kubernetes in 1.0, I was like, surely we'll have this done by 1.2. And then we got to 1.2 and I was like, surely we'll get to this by 1.4. And we've actually had a lot, the rise of Prometheus. Prometheus kind of came out of nowhere for us, which was, it's really just it's a technology like etcd. It's very simple. It does something that was very hard before and makes it really simple and really easy to iterate on. Prometheus has increasingly played a much bigger role in Kubernetes for monitoring it as part of the basis for the metrics that get reported to administrators. And so kind of hopefully, in the next year or so, I'd like to kind of see that loop closed so that a cluster is actively optimizing itself for you, which is, to be honest, is something that the Linux kernel does, and we don't even think about it anymore, but it makes our laptops run better.
That's a great answer. That brings up something. So etcd, people just think of that as bundled with Kubernetes, and Prometheus is something that does not come with Kubernetes. Could you imagine a world where Prometheus gets bundled into Kubernetes?
The bundling question is interesting. So Kubernetes is kind of taken a little bit of a hands-off to the opinionated way to deploy and run Kubernetes. And some of that has been addressed with projects like the Kube ADM project, and there's projects like Kops and KubeSpray and 100 other, as a service, just get Kubernetes installed. I think the answer is yes. One of the things that we've been working on at Red Hat with the Core OS team has been the idea of operators, which is really just a little bit of code that runs on the cluster to double check that everything's okay with a particular piece of software. And so the Core OS teams had built a Prometheus operator that makes it really easy to deploy, an instance of Prometheus and program it with Kube APIs, an example of that extensibility I talked about before. We also, on top of that, they had built the cluster monitoring operator, which is an operator that deploys a Prometheus and it sets up alerts and monitoring and rules to track Kubernetes itself. And it's an open source project anybody can use. We've been actually working really hard to make that be the default in OpenShift. So every time you spin up an OpenShift Kubernetes cluster, you get You get Prometheus, you get Grafana, you get a bunch of alert rules out of the box that help you as an administrator deal with running Kubernetes at scale or in a small environment, be no big deal. That sort of thing, I think, yes, maybe 6 months from now, a year from now, it'd be kind of silly to run Kubernetes without Prometheus on it.
Cloud computing can get expensive. If you're spending too much money on your cloud infrastructure, check out Do It International. Do It International helps startups optimize the costs of their workloads across Google Cloud and AWS so that the startups can spend more time building their new software and less time reducing their cost. Do It International helps clients optimize their costs. And if your cloud bill is over $10,000 per month, you can get a free cost optimization assessment by going to doit-intl.com/sedaily. That's doit-intl.com/sedaily. This assessment will show you how you can save money on your cloud. And Do It International is offering it to our listeners for free. They normally charge $5,000 for this assessment, but Do It International is offering it free to listeners of the show with more than $10,000 in monthly spend. And if you don't know whether or not you're spending $10,000, if your company is that big, there's a good chance you're spending $10,000. So maybe go ask somebody else in the finance department. Do It International is a company that's made up of experts in cloud engineering and optimization. They can help you run your infrastructure more efficiently by helping you use commitments, spot instances, right sizing, and unique purchasing techniques. This to me sounds extremely domain specific, so it makes sense to me from that perspective to hire a team of people who can help you figure out how to implement these techniques. Do It International can help you write more efficient code. They can help you build more efficient infrastructure. They also have their own custom software that they've written, which is a complete cost optimization platform for Google Cloud, and that's available at reoptimize.io as a free service if you want to check out what Do It International is capable of building. Do It International are experts in cloud cost optimization, and if you're spending more than $10,000, you can get a free assessment by going to doit-intl.com/sedaily and see how much money you can save on your cloud deployment. One thing you mentioned a little bit earlier was this idea of being able to schedule workloads more intelligently. I think I heard you say in a presentation I was watching, you were talking about auto-scaling, and I actually thought, I mean, this is Kubernetes, outsider here. I actually thought that like auto-scaling was something that Kubernetes took care of for you, like it's a solved problem, but it sounds like that is not the case. Like people have to, I guess, do some imperative work to automatically scale, or you have to like sort of, read some metrics, and then you have to have a block of code that automates stuff in response to that. Can you tell me about the state of auto scaling, or maybe more about scheduling workloads? Because I think that's a related topic.
Sure. So there's maybe 3 levels. So the simplest level, and this has been in Kubernetes for a very long time, I think it was in Kubernetes 1.1, is horizontal pod autoscaling. So you deploy a replica set or a deployment or a stateful set, and you would create an object that's, hey, I want, whenever I get more than 75% CPU on the pods that this deployment creates, I want you to scale me up. And if I fall below 40%, I want you to scale me down. So that's been in there for a very long time, and that was CPU focused. Over time, we kind of added the second level, which is custom metrics. So this would be, maybe you don't want to scale on CPU, but you want to scale on a business metric. So you want to scale on the number of business transactions that you're handling every minute. And you want to scale up when any particular instance is handling 10 business transactions, and scale down when you have 2. So that support has come in kind of in the last few releases, gone from alpha to beta, and hopefully goes to GA sometime soon. In that case, you have to expose an endpoint and offer those metrics up. It doesn't just happen automatically. Obviously, Kubernetes doesn't know what a transaction means to you. The third part of it is cluster autoscaling. And so there's the cluster autoscaling project has been there for a while. Cluster autoscaling can talk to your infrastructure as a service provider, looking at how many nodes you have and what the workloads that are running on those nodes. And if you drop below a certain utilization, it can say, oh, well, I know I can move these workloads off of the low utilization node and then scale it down. I think what I was talking about before is actually the next iteration of that. So that today is very dependent on building an integration to a cloud provider. And it doesn't always work when, it doesn't really help you update those nodes. So it's not just about auto-scaling, but what happens when you need to roll out a new version of the OS with a security update. You have to go build a new image, a new VM image on your cloud provider that has the latest security patches, and ideally you want to roll that out. But what happens if there's a problem in that version of the kernel or in that version of the kubelet, and your entire cluster goes down because you just naively rolled it out? We're talking about what I was talking about with auto-scaling there is taking that cluster autoscaling to the next level by making an API for managing infrastructure as a service instances, machines, as it were. It's called the Machine API in Kubernetes that lets you, instead of the cluster autoscaler talking to the cloud provider directly, the cluster autoscaler would say, hey, I've looked at the set of your nodes and it looks like you need 2 more. I'm just going to go ask for 2 more. I don't need to know the details of it. So it's a little bit like the horizontal. It becomes more like the horizontal pod autoscaler. Horizontal pod autoscaler doesn't actually go create pods. It just tells something, you need more of these. And with that in place, then that gives us the option to potentially say, okay, well, if I want to roll out a new version of a Kubernetes node, I'm talking to the Machine API, and that's hiding the details of, baking that golden image and running through the test cycle. So that's kind of an evolution. The next level to me would be when you actually run a workload, the node that's running that workload, that pod, or if it's running MySQL, it knows exactly how much CPU MySQL is using. It knows how much memory it's using. It knows how much disk it's using, how much network. What we don't do a great job today of is we know how much you're using. When the scheduler makes a decision about whether to put another pod on that node, it's looking at what MySQL declared up front. Hey, I want half a core. Well, if MySQL is actually, can have half a core, but is limited at 2 cores, and it's running at 2 cores, that's a lot different than if it's just using a half core. And so actually our goal would be to kind of tie together the information about what workloads are actually using to new workloads coming on, as well as to if you've run that MySQL pod 30 or 40, if you've been running that for 30 days and it's always between half a core and a core, you don't really need to tell us that it takes a core. We know. And so doing a lot better job in Kubernetes of just automatically going and saying, well, you didn't tell us that you wanted a core, but every time you've run this before in this namespace, it's taken exactly a core. We're going to go ahead and say up front that we want a core. And that ensures that the nodes are more evenly distributed and workloads run more efficiently. But that also makes autoscaling of the cluster more accurate because the autoscalers can make better decisions about what the resources available on each node are. And that over the long term, that'll help make Kubernetes more of an automatic system. There's a lot of automation today. This will be the thing that makes it really resource aware.
Okay, I want to have some conversation around platform as a service. There's a lot there, and I'm sure we could go much deeper on auto-scaling. Hopefully I'll discuss it in future shows. But the platform as a service conversation around Kubernetes is interesting to me because as a dorm room hacker and building stuff on the weekends when I worked at Amazon and now when I work here at Software Engineering Daily, kind of my side project stuff, I've always used Heroku or Firebase and some AWS services or some Google Cloud services, but the volume of productivity that I've gotten out of platform as a service has been I think it's underappreciated how much more productive users can be on a platform as a service and how nascent the world of platform as a service still feels. I mean, a lot of enterprises are using AWS directly or using Google Cloud directly, and that's great. But it's, there's a question is this the right layer of abstraction for an insurance company or a fintech company to be operating at? Like, do you really need to interface directly with the cloud provider, or is there something in between that would allow you to be more productive? So when you think about platform as a service, what is the right surface area of abstraction for a platform as a service?
So first off, I absolutely agree with you that it is often underestimated how powerful a platform that makes some opinionated choices for you can be. I think the challenge that certainly I've heard a lot, working on OpenShift, which for a long time described itself as platform as a service because, hey, that's what everybody calls themselves, is whenever someone doesn't like your opinions, it's a binary choice. I don't like your opinion, I'm going to go somewhere else. And I always felt that that was something that was a point in time problem. My hope, and I think this is where the reason why OpenShift is built around Kubernetes versus being something home rolled, why when Kubernetes was launched, we were like, yep, this is gonna be it, is Kubernetes really does have a pretty low level boundary. It's at the heart of it, it's really just running a Linux process. And yeah, sure, there's some abstractions above it that dramatically increase the ease of deployment, but you get most of the knobs that you would get if you're just trying to run normal Linux server software. I think that's that's a pretty good ground floor. It's not terribly higher level than the things we run on Linux today. And I don't hear a ton of people saying that the operating system is too complex and we should just throw out drivers and networking and all that and go lower. People are optimizing specific parts of Linux, to do user space networking or to play around with much slimmed down versions of Linux that are still Linux. So if we get Kubernetes right as a low boundary of a distributed system, I think the next level up is somewhere in between kind of the very opinionated guide rails, but incredibly empowering application as a service. So I think that Heroku and App Engine and Cloud Foundry and the opinionated deploy flows that OpenShift and other platforms as a service have had, there's a good layer of maybe I want to run a Linux process, that's the lowest. I want to run a microservice that has just a little bit of state, but not too much. And then I think the third level that everybody's talking about these days is I want to run a really, 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 really simple bit of code, which some people say is functions as a service. You could, call that like picoservices or whatever. I think functions as a service is the term that everybody's using. I want an even more opinionated framework, right? Like Ruby on Rails is a framework that's, lets you write a very small amount of Ruby code and get a running application. Functions as a service is a framework that lets you run a very small amount of code with some defined inputs and outputs and hook into other services really easily. I think those three levels are pretty good. I mean, at the lowest level of Kubernetes, projects like KubeVirt have proved that you can run VMs on top of Kubernetes. That's a pattern that even Google internally uses. They run their VMs inside of containers, and then you can run containers inside the VMs. It gets a little recursive. Microservices are there's a pretty broad middle ground, but a microservice is a concept that most everything that someone builds starts off as a microservice, and just at some point becomes a macro service. But being able to be flexible on that range. So if you grow out of you started your simple web service application and it does an API, and then you want to add 2 more APIs, and then, for reasons organizationally, it's, just you working on it, doesn't make any sense to split. We should be able to grow to the kind of those fat, I hate to say the word monolith, but those big middle applications. And then on the functions as a service end, I think it should be really easy to just stitch a functions as a service in along those other two and, start them up really quickly, be able to drop down into some of the advantages of Kubernetes, and to be able to, when you don't, not even think about Kubernetes at all, not think about containers, just think about, hey, I've got this 100-line function that's going to talk to my object store and then send some information to my Elasticsearch instance. So I think my hope is the platform as a service discussion is we probably have most of the ingredients we need to say, we got this low level, this middle level, and this high level. And then how do we make sure that someone who's writing functions as a service and then grows out of it doesn't have to say, well, I'm going to completely change the underpinning technology and I'm going to have to go deploy a different infrastructure service layer, or I'm going to have to change cloud providers. But I'd really like to be able to say, well, I can have my microservices talk to my functions, talk to my VMs, and have some of that stitching together happen within the single layer of Kubernetes.
And do you think that third layer, does that encompass the things that are sort of like between PaaS and SaaS, like I don't know, one-click Twilio, or one-click deploy my Jenkins, or one-click get a Kafka cluster up and running, or kind of the one-click deploy this big blob of something experience on my Kubernetes cluster? Is that at the third layer, or do you think that's something higher level that will expand?
Today, I would actually argue that's at the second level, because it's really not about deploying it the first time. It's what happens when you need to update it. And, there's a critical security update. Our Helm version doesn't work anymore with that. Or, we're not using Helm charts anymore. Or, the person who wrote that didn't actually support, doesn't update the MySQL instance that comes along with that Twilio template, for instance. Those sorts of examples, I think, fit more in the third layer, which is if you're building it, a lot of people writing their own applications kind of sit in that middle layer where they want to have the tools, but they're going to write a lot of code. When you start talking about running software, I think a lot of that is where we think, and maybe I would call that the third layer, as it's a framework that makes operating software easier. And usually that's just encoding your operational knowledge into some code somewhere, whether you do that with Ansible and a config loop, or whether you do that with a bash script that you're running with a cron job, or whether you're having a human, every Friday come in and run yum update to apply security patches. I think today, a lot of people, when they deploy big packaged software, are kind of in that middle layer, which is they don't quite have the automation they need, or they're using different automation, or it's, roll your own. One of the things we're trying to work is make it easier to use Kubernetes and to have a good coding framework to run some of the software. So example, at Red Hat and at Core OS, operators, which is basically just a simple bit of code that monitors and updates and manages a bit of software running on Kubernetes, making it easier to write those so that someone could come along. And a lot of people have written operator type functionality already. There's an Elasticsearch operator out there that you say, hey, I want an Elasticsearch cluster. I want it to have 3 worker shards and 3 data shards. Go make it happen. And with a little bit of extra work, well, then that can also manage updates. Well, when you upgrade Elasticsearch, you can't update all the data nodes at the same time, or you'll reject queries. So somebody has to write that orchestration logic to say, update the first data node, possibly draining workload off of it, or resharding it, update the second node, shard it back, update the third node. Okay, now we're good. And don't do anything like start a second update in the middle of the first, because that would be very bad. Taking that functionality, having a framework to do it, is what we think of as the operators and the operator framework. There's lots of ways to do it, obviously. I won't make a claim that you can't just go write a bit of code that manages infrastructure. People have been doing that for a very long time. But we want to make it easier and make it easier for people to find and use those operators on top of Kubernetes. And that's a big part of OpenShift, is trying to take these open source projects in the Kubernetes ecosystem, make them work well together, hit the enterprise requirements. Like if you download some software off the internet and it runs great, what happens when you're running $1 million of business on that and the guy who was updating that left the company that it was being paid to work on, doesn't work on anymore? We want to make sure that there's a good ecosystem creating these, and then help those have a long-term history and support them, so that people can run databases on top of Kubernetes in an easy fashion, or run Twilio, not just install it, but keep it up to date, and help folks at Twilio who care about those things also update that software. So really kind of making it so that it's easier to consume software on top of Kubernetes without having to ship a human being to manage that software when you go and deploy it, but instead have the computers do it. They're pretty good at it.
Okay, I know we're up against time. I wanted to just close off with one open-ended question. What do you believe today about Kubernetes and the Kubernetes ecosystem that you did not believe 1 year ago?
Let's see. A year ago, I was pretty optimistic that this thing was working. This year, I really believe it. I was originally pretty uncertain as to how we could build a sustainable community for Kubernetes and, make sure that everyone who was involved felt like they were in working together, able to make progress, have a good set of processes that made sure that the community continued to be healthy. So even as people, change jobs or get pulled off into new projects or get bored of working on Kubernetes or get excited about working Kubernetes and make their first contribution, making sure that there's a good infrastructure for keeping a community together to support the software that I personally believe in. That was a hope a year or two ago. And I've really been impressed by everything that everyone in the community has done to pitch in, to give of their time, whether they work at a company that's paying them to do this or not. I've seen just a ton of selfless behavior. It's representative of how the open source community usually is. And it's really been a pleasure to work with these people who care so much about doing the right thing and selflessly, keeping this software going so that other people can benefit. There's not always a lot of credit given, but it's really been, I've been certainly humbled to work with everyone in the Kubernetes community.
Clayton Coleman, thank you very much for coming on Software Engineering Daily. It's been a real pleasure talking to you.
It's been great talking to you as well. Thank you.
Failure is unpredictable. You don't know when your system will break, but you know it will happen. Gremlin prepares for these outages. Gremlin provides resilience as a service using chaos engineering techniques pioneered at Netflix and Amazon. Prepare your team for disaster by proactively testing failure scenarios. Max out CPU, black hole or slow down network traffic to a dependency, terminate processes and hosts. Each of these shows how your system reacts, allowing you to harden things before a production incident. Check out Gremlin and get a free demo by going to gremlin.com/sedaily. That's gremlin.com/sedaily to get your free demo of how Gremlin can help you prepare with resilience as a service.
Wow!